Hello, everybody. Start to another week. Again, continue with our last chapter, which is chapter 7, the most difficult one in the course. The first 3 sections aren't very bad, but the last 2 are challenging. Just some clarification with the CPT because I have a couple emails. So it will be next week, Monday, Wednesday, I believe I posted it. It will be open for 2-hour time slots. So you'll have to log in, I believe 11 a.m. and make sure you hand in the work back at 1 p.m. If you do not, I told you it was not mandatory. So if you choose not to do it, there won't be a penalty. I know some people have some really high marks and don't want that to be affected. So if you choose to do the CPT, it could only bring you upwards. Okay. If you do not do it, then no penalty. If you do the CPT and you don't do so well, and you're worried about your mark dropping, that won't be the case. Okay, it cannot drop. Your mark cannot be lower than it was at midterms or at the end of March break. Okay, so 7.2, the normal distribution and z-scores. Okay, so we did z-scores, we calculated z-scores in the last chapter, but now we're taking it a step further. We're using something called the table. We're doing the table of it. Let me just grab what the table looks like. So we take the z-score, and remember the z-score tells us how many standard deviations a value is away from the mean. Okay, but now we're going to take it a step further. We're going to take that score and we're going to go to a table. Okay, so I'll show you the table in a second. The z-score table shows the probability. So it helps, so we get the score and now we could find the probability of something occurring at and under a given value. Okay, so the table is in your textbook. It's on page 480. So it looks something like this. A little bit daunting. It's not actually very difficult. Okay, so it's back and front's page 480 and 481. Okay, so it has all these scores. So based on, it has all these values, and all these numbers here are percentages. They're probabilities, like 82% or 82 probability. Go down 94. If you look on this side, we have say 17% here, 36% here. So these are all probabilities. Okay, so their probability is based on your z-score. So I'll show you how to use this table. It isn't difficult to read. It's just a lot of numbers, but it's very, very simple. Okay, so when we get to the question, I'll pull this back out. All right, so that's the z-score table. And again, it tells us the probability of that value and everything under it. Okay, so occurring at that value and under that value. Okay, so I'll show you with an example. Okay, number 1, a men clothing store kept records of the waist sizes of a sample of their customers. Remember, sample. Okay, measured to the nearest quarter of an inch. The table shows the frequency. So here are the different waist sizes, and these are how many people were in those ranges. Okay, so A is add a relative frequency column to the table, which I have already done. And for question B, what is the probability that, now let's complete this relative frequency. So relative frequency is RF, and it is the frequency divided by the total number. So it's the frequency divided by the total number. So we're going to find N is the total here. So I don't know what that value is. So 120 plus 177 plus 180 plus 96 plus 27. I get 600 here. Okay, so our sample is 600 people. So we're going to take the frequency of each one and divide it by the total number. So this was obviously 0%, or just 0. This is 15 over 600. Then 105 over 600. 177, 600, and keep going. Okay, so let's calculate each one of these. So So we get 0.025. 0.7, 0.175, 0.295, 0.3, 0.16, and 0.045. Okay, so those are the relative frequencies. Okay, so you could turn these percentage, so that'd be 2.5%, 17.5%, 29.5%, 30%, 16%, and 44.5%. Okay, so what is the probability the customer has a weight size between 30 and 32? So between 30 and 32, we have 17.5%. Okay, more than 36. So we have to go larger than this column here. So we add these two together. So 16% plus 4.5% will give us 20.5%. Okay, so we add those two. And lastly, exactly 38. Okay, so this is kind of a trick question. So we have exactly 38. So 38 appears in both columns, okay, or both rows, sorry. And since these don't give us any exact measurements, we don't know if these are 38 exactly or 38.1 or 37.9. We don't know the exact value. So whenever you see exact, the answer is going to be 0%. Okay, because we don't actually know what the values are here, and the chances of someone's waist being exactly 38 is very unlikely. So right now we just do put 0%. So whenever you see the exactly here, it is 0%. Okay, next one. Okay, Joshua is trying out for the school football team. He wants to know how far he can kick the ball for a field goal. The table shows the data of 16 trials. If you don't know what a field goal is, don't worry about it. Just know that he's kicking a football, okay? And he's kicking the football, and these are how far every time he kicked the ball, these are the distance that he kicked them, okay? And these would be in yards, okay? So these would be in yards. That's the units. Okay, so A, determine the sample mean, and the standard deviation. So the mean, so sample mean is X bar. If it was a population, it would be mu. So X bar, so we're going to add them all up and divide by how many there are. So 17 plus 27, keep going all the way to 38. And we're going to divide by how many we have, which is 16. Just wondering if I have any answers here. I didn't pre-do them, so let me just type this in quickly. So 5555 divided by 16. So his average is 34.7 yards. All right, so then it's asking for the standard deviation. And yes, that's that very long thing. We don't have to make the chart at this moment, but standard deviation of a sample is the square root of x minus x bar squared divided by n. But since we're doing a sample, it's n minus 1. Okay, so we're taking each value, subtracting the average, and squaring it. Okay, so we have to take each one I'm not going to write them all out. So the first one would be 17 subtract 34.7 squared plus 27 minus 34.7 squared, and keep going. Okay, remember the 1727 are these values here. Then we're going to go all the way till we get to the last one, which is 38 minus 34.7 squared. Okay, then divided by n minus 1, so 16 minus 1. Okay, so what I got in my notes, I did this one. So I get 1353.44 divided by 15. 1353.44 divided by 15 gives us 90.2, and then we're going to square root that one. Square root it, and we get 9.5 rounded. Okay, so the average, the mean, is 34.7 yards. Okay, and the standard deviation is 9.5 yards. So remember, the standard deviation tells you the average distance. Any value is away from the mean. Okay, so on average, any kick will be 9.5 yards away from the mean. Just give me 1 second. Okay, going on to the back now. Now it says, what is the probability that Joshua kicks a distance of less than 30 yards? Okay, so now from here on out, when they're asking for the probability, we are going to use the z-scores. So going back to what we did in the first page, when I was saying the probability from the z-score table probability. So from now on out, we are going to calculate the probability using the z-scores. Okay, I know we're given values here, and you could just, I don't want you to use these values to calculate the probability of less than 30. Okay, so we're going to use z-scores. So this is how it works. So z squared equals your value, subtract your mean, divided by your standard deviation. So we're looking at the value of 30. So 30 subtract our average, which is 34.7, divided by your standard deviation, which we calculated to be 9.5. And when we calculate that, you get, let me see, 30 subtract 34.7 equals, divided by 9.5, gives us roughly negative 0.49. Okay, we're going to use 2 decimal places always when we are doing our z-scores. Okay, we'll round to 2 decimal places. Okay, so now this is how the so this tells us that 30 yards is 0.49 standard deviations lower than the mean, because we have the, lower than the mean because it's a negative, so it means lower than. Okay, but we're not looking for how far away it is from the mean, or how many standard deviations it is away. We're looking for the probability here. So now we go to the table. Okay, so we're going to go to the table, and we're going to find out where the probability of the z-score of negative 0.49. Okay, so this is how the table works. Okay, so we go down to here. So these are negative 2s, negative 1s, and negative 0s. Okay, so we first do our whole number, our 1s. Okay, so our 1s, we're at negative 0. So we're going to go looking at these negative 0. Okay, but now we have negative 0.4. So we're going to go to this row here of negative 0.4. And then what we're going to do is go across to where, so this is the 1s and the tenths. So our 1s and our tenths. So negative 0.4, we look in this column here, we find negative 0.4. And now going across to our hundredths. So our hundredths is 9. So we're going to go across to where it's 9. So 9's over here. So this would be, so we go across all the way across to where it is 9. So negative 0.49. So we get the answer here of 31.3121. Okay, so again, negative 0.4, and now we have to go all the way over to where 9 is. So 9 is over here, so we go down, or you go across, so negative 0.49, which is 0.3121. So we go to the table, and we get 0.3121, or 31.21%. Okay, so the probability of Josh kicking a distance of less than 30 yards is, I should have put 30 yards or less. Messed up the question. It should be 30 yards or less. Would be 31.21%. Okay, so again, going back to the Z-score table, it's the probability occurring at that value and under. So at and under a given value. So what we just calculated here was 30 yards and less. So this is the probability of 30 yards or less. Okay, so now a little bit kicking it up a notch. So C is, what is the probability that he can kick between 20 and 40? 20 and 40. Okay, so we are going to do 2 scores here. So we're going to do it for 20 yards, and we're going to do it for 40 yards. So we have 20, subtract our average, 34.7, divided by 9.5, and 40 minus 34.7 divided by 9.5. So here, 20 minus 34.7 divided by 9.5, I get an answer of negative 1.55. And here, I get an answer of 0.56. Okay, so whenever they're asking, when they ask for the probability again, so probability, so we're going to the Z table, and we're giving 2 values, so we're going from a range of 20 to 40, you need to do 2 Z-scores. You need a Z-score for 20 and a Z-score for 40, and I'll show you what happens. Okay, so negative 1.55. So go to the table. So remember, this is the ones and the tenths. Okay, so negative 1.5, because it's 5. So negative 1.5, and now we're going to go over to where 5 is. So 0, 1, 2, 3, 4, 5. So here. So that's the 5th column here. So 0.0606. So we go down to the table, and we get 0.0606. Okay, now we're going to do the same for 0.56. So one side it's negatives, the other side is positive values. So we're going from 0.5. So 0.5 is here. And then over to the 6th. So the hundredths. So 5.6, which would give you over to here. So 0.7123. Okay, so this is the Z-score. Now we get the probability. So we have 6.06% and 71.23%. Okay, so we're not finished it just yet. So this percent tells us from 20 yards and less. This tells us 20 yards and less. This value here tells us from 40 yards and less. Okay, so think about it like this. So we could kick a distance, say 20, and we could kick a distance of 40. So this value here actually tells us this percent here. It tells us all this percent here. So less than 20. But we do not want to know less than 20. We want from 20 to 40. Okay, so I know this is we don't really need this information, but you'll see where it comes useful. Then the 40, so 71.23% is all the values under 40. So this is 6.06%, and the 40 from 40 under is 71.23%. So to kick under 20 yards, it's 6.06%, but to kick under 40%, it's 71.20, sorry, under 40 yards is 71.23%. But the 40 includes everything from 40 all the way down to 0. And this 20 represents 20 all the way to 0. So if we want to find just this percent here, what we do is we take the 71.23 and we subtract the 6.06, and that will give us our range from 20 to 40. So now 21.23 minus 6.06, and we get 65.17%. Okay, so whenever you're given a range, you're going to do 2 z-scores, and then go to the table, and then you just subtract the values. So whenever you're given a range, 2 z-scores, then go to the table, get the percentages, and then subtract them. Okay, I believe that's all for this lesson. Okay, so try this out. This is probably one of the most important lessons of this chapter, which is figuring out the probability. The homework here is listed at the bottom. So page 341, 1, 2, 3, 5, 6, 9, AB. I hope all is well, and we will touch base in a couple days. All right, take care. Bye.